Thanks. So I just highlighted in green that we're raising both sides to the second power, and that's because we have the square root here. So when we take the square root of something and raise it to the second power, we're just left with what was under the radical. So this is 5x plus 11. Now on this side, this is x plus 1 to the second power. So we can think of this as x plus 1 times x plus 1. And we could use a box or some other method to multiply. So I'm going to use FOIL this time. The first term, x times x is x squared. The outside term, x times 1 is positive 1x. The inside term, x times 1 is positive 1x. And then the last term, 1 times 1 is 1. And then we have like terms here. So this is 2x, so we have x squared plus 2x plus 1 equals 5x plus 11. If this is something you need more help with, it's just something that you should ask about, this multiplying binomials part. This is a review of Algebra 1 that we've also seen. Okay, so we squared both sides and simplified that. And if you remember, step 3 is to equal the equation to 0. So let me get this side equal to 0 by subtracting off the 11. X squared plus 2x minus 10. And now subtract off the 5x also, so we're left with just 0. We have 0 equals x squared minus 3x minus 10. So what we said now is that you can solve either by factoring or by using your calculator. So if you graph this on your calculator, you're going to see something that looks like this. That at x equal 5 and at x equal negative 2, you have zeros of this thing, if you graph it on the calculator. So that's one way to get your solutions here. X equal negative 2 and x equal 5. The other way to do it is to factor this. And I'm not going to show the process of factoring right here, but the factors here would be x minus 5 times x plus 2. And we would set those equal to 0, so x minus 5 equals 0, so x equal 5. X plus 2 equals 0, so x equal negative 2. Okay, so we have our possible solutions. And now we're asking ourselves, do they actually work? Because when we have a radical function, we have to plug in and check they may not work. Okay, so here we go, plugging in x equal 5. Okay, so we got to go inside parentheses and say that we're looking at 5 times 5 is 25, plus 11 is 36. So 2 times the square root of 36 minus 2 equals 2 times 5, 10. Okay, the square root of 36 is 6. So this is 2 times 6 minus 2, and asking, does that equal 10? This is 12 minus 2, which is 10, which equals 10. So x equal 5 is good. It works. And that's what we expected. But now we do need to plug in x equal negative 2, because we did get it as a possible solution. So here we go, 2 times the square root of. So here you have 5 times negative 2 is negative 10. So you have negative 10 plus 11 here. This over here is 2 times negative 2. Okay, now we do negative 10 plus 11 is 1. So you have 2 times the square root of 1 minus 2 equals 2 times negative 2 is negative 4. So the question is, does this equal negative 4? The square root of 1 is 1. 2 times 1 is 2. So we have 2 minus 2 equal negative 4. 0 equal negative 4. That's false.
Right.
So then we would reject x equal negative 2 as a solution and only keep x equal 5. And that's how you solve radical functions.